Okay, so challenge. Biologist records the height of plants, okay, X centimeters. 20 plant seedlings. She calculates the mean as X bar is equal to 3.1 centimeters. And she calculates the standard deviation as 1.4 centimeters. Okay. The biologist subsequently discovers she's written down one of her values incorrect. She replaced a value of 2.3 with a value of 3.2, just to get confusing there. So it was, she replaced a value of 2.3. So 2.3 is correct, and 3.2 is the wrong answer. Okay, so she replaced the value. And one of the values incorrect. She replaced it. No, we've got that the wrong way around, don't we? Calculate the new mean and standard deviation of the data. So 2.3 is the incorrect one because she has replaced that one. And this one is the correct one. Okay, so these bits of information are made by with the 2.3 in them. So we've got an n of 20. Okay, work out the correct mean. So at the moment, X bar is equal to 3.1 times 20, okay, to get the summation of it, and then divided by 20 sort of thing. So we can put it down, and that's not going to be X bar at all. It's going to be the sum of X is going to be equal to that, which is going to be 3.1 times 20, which gives us 62. Okay, and then we take the 62, we divide it, we get it. Okay, so now what we need to do is we need to take away 2.3 because that's what we've got wrong. Okay, and that gives us 2.3, and then add the new answer in 3.2, which gives us 62.9. And so now we can find the new X bar will equal the 62.9 divided by the 20 plants. Okay, which is 3.145 centimeters. Okay. Now then, if we take a standard deviation, okay, and do a similar process, what do we have? The mean and standard deviation. So we know that the standard deviation is equal to the square root of the sum of x squared over n minus the sum of x over n squared. Okay, this second bracket here is basically the mean. Okay, so we know that 1.4 will equal the square root of the sum of x squares over n, which we know is 20 plants, minus the original 3.1 centimeters squared. Okay, so we can find out what the sum of the x squared is. So we can do that. We can do 1.4 squared. We can add 3.1 squared onto it, and then we can multiply everything by 20, and that will equal the sum of x squared. Okay, so 20 times 1.4 squared plus 3.1 squared, and we get 231.4 equals the sum of x squared. Now, if we take a wrong answer, which was 2.3, we need to take 231, and we need to take away 2.3 squared, and we need to add the 3.2 squared onto it, so that we get a new summation of x squared. Okay, so 213 minus 2.3 squared plus 3.2 squared is 236.35, and we can now use that to find the new standard deviation, which is going to be the sum of x squared, which is the 236.35 divided by the 20 plants, take away the mean, and we need to use the new mean, so 3.145, squared, to give us a new standard deviation, which hopefully, divided by 20, is 1.3879. So did they do one decimal place? 1.38, 1.39 centimeters. Okay, bit messy. So just a bit of a pure question, really, of reworking all the formulas. All right, that's the challenge. That's the end of chapter 2. Chapter 3, representing data next.